Hi, this is Kevin Trainer, and I'd like to welcome you to my tutorial video on adding foreign keys to implement relationships. This is part of a group of tutorials that I've been doing on logical database design. And as you can see from the graphic that's up, adding foreign keys is the very last of the tasks to be done under this overall task of logical database design. So adding foreign keys to implement the relationships. Why are we doing it? Well, relational databases expose some of their plumbing. Okay? In particular, they expose the plumbing of how the relationships actually work. So instead of just having a connection between a row in one of the tables and a row in another one of the tables, and having it be kind of magic invisibility that connects them, we actually see the mechanical part that connects them, and that is we add a column to one of the sides, and that holds a foreign key, and the foreign key points to another table in which that value can act as the primary key. Okay, and that's how the connections are implemented. So let's take a look at an example of one. Okay. So let's take a look at course offering and course. Okay. Now, first, let's take a look at course. Here's the method that I want to teach you. You look at the entity relationship diagram and you say, does this table participate in any relationships in which it's on the many side? Well, not for course. It participates in one relationship and it's on the one side of it. So it doesn't need any foreign keys. Foreign keys always point from the many side to the one side. And we only put foreign keys on one side or the other. We don't put them on both. So why don't we put them on both? Well, we don't put them on both for two reasons. One is we would have a redundant fact. Okay, we would be representing the relationship with two facts in the database, and they, of course, could get out of sync with each other. And so because of our normalization commitment, we don't want to do that. And the other one is, although we only put the foreign key on one side, we have an index that we create that's associated with the foreign key that allows us to travel the relationship in the other direction. So the data that we populate right into the foreign key column allows us to travel the relationship in the primary direction. But the index that's created associated with that foreign key allows us to travel it very efficiently in the other direction as well. So we only need to point from one side to the other. We always point from the many side to the one side because you can't effectively point from a one side to a many side because you'd have one row trying to point to more than one row in the other table. Well, the only way you would be able to do that would be with a repeating column, and we don't allow repeating columns. So when you look at it the other way, each row in the many side table has one column, that's the foreign key, and that points to the row that it's associated with in the one side table. So how are we going to do this? Well, let's look at course. Okay. How do we put a foreign key over here? We don't have course ID. We have a lot of things, but not course ID. So let's insert an attribute after. Okay. And let's have that be course ID. All right. And course ID is an int. Okay. And then the other thing we want to do is we want to mark it as a foreign key. So highlight it, right click, set foreign key. Say. So whenever we see a relationship, we should have a foreign key on one side, and it should always be on the many side, pointing at the one side. Okay, let's do it again. All right, we have the same kind of relationship between course offering and location. All right, let's add location ID. So let's insert attribute after. Let's say it's a location ID. All right. And let's say that that's a foreign key as well. Set foreign key. Okay. So far, we have connected the course. And we've got these two crossed right here. So let's try to uncross them if we can. Okay. It's always good to not cross the lines. All right, so that's working fine. Now we've got location and course. We've got semester ID pointing to semester. Well, because it was part of the course offering key, because course offerings identity is dependent upon the identity of the semester. Some people would say that this makes course offering a weak entity rather than a strong entity, but we're not going to worry ourselves with that today. Because of that, we already have in our key field, we already have semester ID. Well, what do we have to do? Well, let's just mark it as also being a foreign key. And that's done. So semester's taken care of. All right, that's good. And now we have the same relationship with instructor. So we don't have an instructor ID there. Let's add it. So let's add another attribute. Let's say that that's instructor ID. Okay. And let's mark that as a foreign key. Okay? And that's all you have to do. So course offering has a foreign key for every one of the relationships. It has 1, 2, 3, 4, 5 relationships. Oh, I'm sorry, it's got 4 in which it's on the many side. And so it has 1, 2, 3, 4 foreign keys. Okay? Whereas instructor, semester, location, and course don't participate on the many side of any relationship, and you'll see they have no foreign keys. Okay, that's pretty easy. What about these things that have associative entities? They could be a little tricky. All right. So let's look at a pretty easy to see one. We've got system user permission and use case. They're all very close to each other. All right. So if we look at the 3 of these, which of these are on the many side? Well, permission, because it's an associative entity or table, it's on the many side in both cases. So it needs foreign keys. Oh, that's how we built them. So use case ID is already there to be the foreign key to use case. So all we need to do is market as also being a foreign key. And user ID is already there for system user. Okay, so let's mark that as a foreign key as well. So on these associative tables, you'll find that because the primary key of an associative table is a combination of the primary keys of the primary tables themselves, these columns are both primary keys and foreign keys. And let's look at another associative entity or table. It's one that we added called attendance. Okay, and this is what connects class meeting with student. Okay, and so we have student ID to connect it to students. So let's identify that as a foreign key. Set foreign key. And now we have these 4 remaining key columns are what connected to, they are the primary key of class meeting. So all 4 of them are also foreign keys. So we're going to set that as foreign key, set that as foreign key, set one more, and yet one final one as a foreign key. So here again we have an associative table or intersection table, depending on the terminology you want to use, and all key columns, and the key columns are participating in both primary keys and foreign keys. Okay, and then we had one more associative table that we created to connect student and course offering called registration. And again, student ID is what points to the student table. And so let's take student ID and also mark it as a foreign key. And then what does it take to point to the course offering table? Well, it takes a semester ID, a course number, and a section ID. Well, that's just what we have left. So these are going to be marked as foreign keys as well. Foreign key, foreign key. Now we've pretty well done everything, I think, but here's what we're going to do. We're going to take a look and just make sure that we've got it all done. Maybe I can get that to move a little bit. Yeah. Well, that's okay. So let's look. Student is okay. It's not on the many side of any relationships. Registration, we've already done. Course offering, we've already done. We've already looked at instructor, semester, location, and course. Let's come over here. Attendance, we've already done. We've already put the foreign keys in it. Class meeting, okay. Does it participate on the many side of anything? Yes, it does. It is on the many side, and it's pointing at course offering. So what does it take to point to a course offering? Well, it takes a semester ID, a course number, a section ID. Well, turns out that these are part of our key. So let's just take semester ID, set that as a foreign key, course number, set that as a foreign key, section ID, and set that as a foreign key as well. So we have all the foreign keys that we need here. So let's just see if we have anything else left. We've got a couple down at the bottom. So system user, does that participate in any relationships, or it's on the many side? No, it doesn't. Doesn't need foreign keys. Use case, is it on the many side of any relationships? No, it's not. Doesn't need foreign keys. And then we already took care of the associative table permission. It's on the many side in 2 cases, which is why it's got the 2 foreign keys. So it's pretty easy. You just look at the symbol for the table, and you look to see whether it participates in any relationships from the many side. And if it does, then it needs enough foreign key columns to point to the primary key of the table on the other side of that relationship. And that's what we've done with every one of our tables. So now we have completed the last of the steps. I'm just going to save that. No, I'm going to save it under a different name later. So we won't save it. But I'm going to come back. So what have we done? Well, we have added foreign keys to implement the relationships. And that's logical database design, okay? So what did we do in total? Well, we began by refining the conceptual data model. And then we converted attributes into columns. Then we made a lot of changes for normalization. Then we resolved the many-to-many relationships. And then finally, we added foreign keys to implement the relationships. And now we're done. So that's it for logical database design. Until next time, I'm going to say bye-bye.